lectures or these videos to my YouTube channel. Do my best, right? There's no promises. Here we go. All right, so Chemistry 3101. We finished Chapter 4 in the last lecture. What's today, 25th? So it would have been on the 23rd. And I was lecturing from my office that day so that I could use my molecular model kit. And I think I brought it home. It's somewhere in here. Anyhow, if I need to refer to that today, we'll do that. So anyhow, let's start out by practicing some nomenclature. We went over all the rules of nomenclature last class, and we said that there's 8 alkyl groups that you need to know, right? You need to know what a methyl group is. You need to know what an ethyl group is. Then you need to know propyl and isopropyl. You also need to know butyl, isobutyl. And then there's 2 that are hyphenated. So sec, butyl, and tert butyl. So you need to be very aware of all 8 of these alkyl groups. Are there other ones? Yes, absolutely there are, but we're not worried about those. All right, so I'm going to ask my students who are online with me right now, did anybody find the longest carbon chain in the molecule in question number 1, where we have to provide an IUPAC name? Could anybody tell me? Yes, 7. Somebody says 7. Absolutely. So if I say 1, 2, 3, 4, 5, 6, 7, that's a chain. That's pretty long. That's 7 carbons. But Katana, I could also go 1, 2, 3, 4, 5, 6, 7. So I could do either one of those. I could do the pattern or the path that I have in green, or the path that I have in yellow. Could anybody tell me which one is the correct one? Because there's only one of them that's right. And there's one that's wrong. It's the green one. Sarah, why is that? You're right. I agree with you. Absolutely. There you go. So Sarah says it's because if you choose the path in green, it has the most substituents. Absolutely. So if we go back here to the one in yellow, you would only have 1, 2 substituents, right? Okay, so it seems maybe that it's reasonable. But if you follow the path in green, 1, 2, 3, 4, 5, 6, 7, in that case, we have 1, 2, 3 substituents, and we want to find the longest carbon chain with the most substituents. Okay, so we'll put here longest chain with the most substituents. All right, there we go. Okay, so I'm going to highlight this carbon in blue, and I'll highlight this one in red. And this is not a trick question. I've told you how many times I detest trick questions. Could anybody tell me where should I start numbering from? Should it be from the blue carbon or the red one? Absolutely. Absolutely. Okay, all my students are nailing it. Okay, perfect. Thanks. Kiana, Hannah, thank you. Okay, I'm going to start from the blue one. Why? Because I want to give the first substituent the lowest possible number. And the first substituent would be that methyl group, right? The other 2 are ethyl groups. So just give me a sec here. I'm going to erase some of this stuff just to clear it up a little bit. So let's number the carbons. We have 1, 2. There's that methyl group at carbon 2. At 3, we have an ethyl. 4. At 5, we have another ethyl. 6 and 7. So the parent of this compound is heptane. So we've got some kind of heptane. Then we have a 2-methyl and a 3,5-diethyl. Well, E comes before M in the alphabet. So we're going to put 3,5-diethyl, 2-methyl heptane. All right, and that would be the IUPAC name for this compound. Just as a reminder, when you're naming a compound, remember there's no separation between letters. So that's why we have methylheptane all as one word. Whenever you have a number in a letter, doesn't matter if the number is before or after, we separate using a hyphen. And then when you have numbers are always separated by commas. Okay, so numbers by commas, a number in a letter, doesn't matter the order, it's separated by a hyphen. And letters, we don't put spaces in between, the parent and any substituent before that. Okay, well, with all that in mind, I bet you we're going to get this one even faster. Could anybody tell me what the longest carbon chain in the one in number 2 is? How many carbons are in it, or if you want to name it, that's fine. Yeah, absolutely. Thanks, Sarah. It's octane, right? The longest carbon chain has 8 carbons. And so if we highlight that chain, we have 1, 2, 3, 4, 5, 6, 7, 8. You know, and sometimes I'll have a student who will say, um, actually, in this one, I think that's the only path we can take. Anyhow, so sorry, I digress. There we go. So we have our octane. And if I highlight this carbon in red, and if I highlight this one in blue, where should I start numbering from? Either way, you have a substituent on the third carbon, don't you? So you have to go for the tiebreaker. So could anybody tell me? Yeah, I'm going to start on the red carbon, right? Because the ethyl group would be the tiebreaker, right? Oops. Sorry, I didn't mean to do that. Okay, let's go back here. Somebody keeps bugging me. I'll have to turn my phone off after. All right, so let's see here. Where the heck was I? So I'll erase all this spinach here, and I'll just number the carbons. So we've got carbon 1, 2, 3, 4, 5, 6, 7, 8. So I've got a total of 8 carbons, and thus this is some kind of octane. Some kind of octane. Then our substituents, let's see here. We've got a methyl group at carbon 6. We've got a methyl group at carbon 3. So that's a 3,6-dimethyl. And then we have an ethyl at carbon 4. Well, E comes before M in the alphabet. So we're going to put 4-ethyl. 4-ethyl. And then what was it? 3,6. 3,6-dimethyl. Dimethyl octane. 4-ethyl. 3,6-dimethyl octane. Give me a thumbs up if you follow me on the rationale of that. Because if you understand those two, you really have a good handle on it. So somebody says, can you explain the tiebreaker? Sure. So if we count from carbon 1 on this end, we go 1, 2, 3, and we have a substituent. If you were to number from the other end, 1, 2, 3, you have a substituent here. So you can't number from each end or either end based off of the first substituent. So if you follow the numbers in green, you go 1, 2, 3, 4, and you have a substituent. Where if you followed my numbering in black, the second substituent would come after 3, 4, 5. Okay, so 4 is a lower number than 5, and that is how we use the tiebreaker rule. All right, let's see if we can name a bicyclo compound. Okay, bicyclo compound. So just to do a little review with you, if you remember, we call this carbon here and this carbon here, we call those the bridgehead carbons. You can see that both of the bridges that actually have carbons in them, they both have 3 carbons. There's 3 carbons in this bridge, right? There's also 3 carbons in this bridge. They both have methyl groups on them. But which star would I start numbering at? Maybe I'll change this one to a blue star. All right, should I start numbering on the red star or the blue star? Could anybody tell me? We'll start with that. Red or blue? Remember, I want to give the first substituent the lowest possible number. No, it can't be the blue one. Yes, okay. Because if you had the blue one, the shortest path would be 1, 2, 3 to the methyl group, to the one of the methyl groups. But if you do the red one, you have 1, 2. So your first methyl group would be at carbon 2. There you go. All right, so we're going to number it using the red numbering system. So let me just eliminate those. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it's some kind of bicyclooctane. So let's scribble that down first. Maybe I'll put it here. We have a bicyclooctane. And I forgot to put my numbers in there. So let me just do. There we go. So we have bicyclo something octane. All right. So could anybody provide the numbers that are going to go inside the square brackets here? I think I need more coffee. What would the numbers be? Yeah, thanks everybody. Yep, everybody got it correct. It's 3, 3, 0. If you're still struggling with that, right, we have 3 carbons in this bridge. We have 3 carbons in this bridge, and then there's no carbons in the middle. So we have 0. And then we have a 2,7-dimethyl, so we'll scribble that down. 2,7-dimethyl bicyclo 3,3,0-octane. All right, a little bit of bicyclo nomenclature. Let's move on to number 4. Just give us a plain old IUPAC name. Did anybody do this one and find the longest carbon chain? I did it. I've done it a few times. Anybody found the longest carbon chain in this one with the most branches? Yeah, it's nonane, isn't it? Okay. Well, so yeah, absolutely. So Sarah or anybody back here, where was I? If I was to highlight this carbon in green, yellow, and highlight this one in green, where should I start numbering from? The one in yellow or the one in green? You can probably see that pretty quickly. Yeah, it's the one in green. Absolutely. So the longest carbon chain, in case you didn't find it, is 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. So let's see, what are our alkyl groups? We got a methyl group here. We've got an ethyl group here. Could anybody name this big one here? Anybody practice? Could anybody name this alkyl group? It's a 5 something, obviously. Non-named. Yes, it's the sec-butyl group, isn't it? Thanks, Sarah. This is the sec-butyl group. Yes, very good. The sec-butyl. All right. Remember the sec-butyl, you have a methine with a methyl group attached to it, and then you've got a methylene and a methyl. So that's a sec-butyl group right there. All right, so we've got ethyl. That's going to come first. So we'll put 4, or sorry, sec-butyl, my mistake. We have the letter B. That's going to be first. So butyl, then ethyl, then methyl. That's right. So we have 5 sec-butyl. Remember, we ignore the prefix sec. Then we have a 4-ethyl. And then the last substituent is the 3-methyl. 3-methyl. And like somebody said earlier, it's a nonane. And you're done. All right. So it's just a matter of applying the rules methodically and writing down the answer. All right, let's move on to the next one, number 5. Oh, wowzers. We have a big old group here. So could anybody tell me the longest parent chain is this 8-carbon ring? How would you name that ring? And it's not a trick question. I went over it with you in lecture. I even drew it. I drew this ring. I think I did anyway. I did. It's a cyclo something. What would this ring be? Cyclooctane, absolutely. Cyclooctane. Thanks, Sean. Absolutely. And now this group that's over here, now this group is way too big. We don't have any common name for this guy, so we've got to come up with a name for it. All right, so what do? We count the number of carbons in the longest chain. So we have a butyl, and then we have a 1,1 dimethyl. So this group, you would call it a 1,1 dimethyl butyl. All right. So 1,1 dimethyl butyl. So we have 1,1 dimethyl butyl cyclooctane. So we can just put all that together. Got 1,1 dimethyl butyl cyclooctane. Somebody asked a question, are all the names alphabetized no matter what? The names of the substituents, yes, are always put in alphabetical order. Yes. All substituents are in alphabetical order. And remember, we ignore prefixes, except which ones? What are the prefixes we don't ignore? Iso, right? We don't ignore. So do not ignore iso, cyclo, and neo. Those are the 3 we don't ignore. Great. All right, the next one. These ones should go much faster, just drawing a structure. 3-ethyl 2,4,6-trimethyl octane. So the way you're going to do this is when your pen touches the paper, you see that blue dot that I put there? That's carbon number 1, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. Right? I repeat, okay? If it's an octane, when your pen touches the paper, that's the first carbon. 1, 2, 3, 4, 5, 6, 7, 8. So there's our carbon chain. If we go to carbon number 3, we have an ethyl group. On carbons 2, 4, and 6, we have a methyl group. Yes, just give me 1 second. All right. And there we have our compound. All right, so we have our our 3-ethyl 2,4,6 trimethyl octane. Let's give the next one a shot, where we have a 3-ethyl 2-methyl pentane. So if we have a pentane, when our pen touches the paper, that's the first carbon. So let's start here. 1, 2, 3, 4, 5. If you did it like this, 1, 2, 3, 4, 5, no problem. You're still going to get the right answer. On the third carbon, we have an ethyl group. If we do it on the other one, we're just drawing the same thing twice. We have on the third carbon an ethyl group. And on carbon number 2, we have a methyl group. And there you go. So these two compounds that I've drawn are identical. All right. The next one, you have 1-cyclopropyl 3-methyl cyclopentane. So our parent is going to be cyclopentane. So we're going to scribble a cyclopentane down here. On the first carbon, we're going to put a cyclopropyl. So a cyclopropyl looks like this. And on the third carbon, we'll put a methyl. Done. There we go. Give me a thumbs up if you follow me on 6, 7, and 8. Everybody with me on those three? 6, 6, 7, 8. Anybody with me on those? Okay. All right. I'll assume that you're with me unless I get a question. All right. Let's move on to the next one. Something a little more challenging. We have to draw a Newman projection as if we're looking down this carbon-carbon bond. So we take our eyeball and we look down this carbon-carbon bond. So we're going to start with this carbon in the front, this one in red, and then we have this carbon in the back. So our carbon in the front is going to be this little dot, and then the carbon in the back, remember, is going to be this circle like that. All right. So what do we have that's going to be going straight down on the carbon in the front? Anybody could tell me what's going to be going straight down? There you go. It's going to be the chlorine. Okay, so I've got a group going up and to the left and another group going up and to the right. Could anybody tell me the methyl group that's drawn there on the wedge, is it going to be on the left or the right? And it's not a trick, just a regular old Newman projection. Will that methyl group be on the left or the right? Cha, thanks, Eric. That's right. Eric coming in with the clutch here, okay? Exactly. Maybe I'll draw it backwards. I like it. It's prettier that way. Okay. Then we have a hydrogen over here. So that's this proton, which isn't drawn. All right. Then going straight up in the back, we have another methyl group. Put a CH3 group here. Then we have a group going down into the left and another one coming down to the right. So the bromine, is it going to be on the left or the right? Anybody? And again, there's nothing trying to fool you here. Go for it. Go with your gut. Absolutely. Thanks, Katana. Yeah, the bromine's over here. And of course, there's a proton that's not shown. Right? There's a proton coming out here. There you go. A little bit of Melvin Newman for you. All right, let's try another one. Actually, let me see here. Could we take a short break? I would like, because I'm going to assume, and I don't mean this in a bad way. Let's just take a short break. Hold on. Okay. Can everybody still see my screen? I think they can. Okay. I just didn't want to record something that why is this button still on? I guess I'm not recording. Anyhow, let me make sure. There's certain things I don't want said on my YouTube channel. Yeah, I guess I'm not recording. Okay. I'm going to assume that not everybody did all of these because you're all very busy. And I know that some of you work full time and stuff. Could we take a short break and everybody try 10 and 11 at least? So try 10 and 11 and keep going, of course. But I'd like everybody to try drawing a Newman projection on their own. I'm going to leave the screen up. And try 10 and 11, and then we're going to come back. Why don't we just come back at like 8:39 in 10 minutes, and we'll go over these ones again. Okay, so 8:39. Actually, I'm not going to leave the screen up. I suppose I can. Anyhow, 8:39, we'll come back and we'll try these ones.